Hi guys, this is the Jacobitz Learning Group. Thanks for watching. We're going to do two problems on geometric sequence. Okay, so let's look at what a geometric sequence is. And in the first place, it's a number by which each term is multiplied to get to the common ratio. So common ratio is here. Why are we using a common ratio? Because let's say we were climbing this, let's pretend this is Mount Everest, and this were a ratio of 3, so this would represent hypothetically 6 feet. And then this next ratio would represent 12 feet, which would double. And then if you were doubling, it would be 24. But if you were adding in terms of 6, it would be 18. So whatever the ratio is how you multiply. And I did each one of these shades here as a gradient to, see, like if somebody were really climbing this up and they did it in times, like we're going to climb here for 2 hours and take a break, then go 2 hours in this, you climbing up a certain amount, and there's a way to do it at equal limits so you can actually plan it. Well, that's what a common ratio does. So, not if you're climbing mountains, but anything. Like if you're, some of you are investing in oil and mines and this and that, they have to have a common ratio to decide how far they're going to take a drill down or what they're going to do. They have to know feet and limits. And some of you people might want to work for them. Might be good to know that. So anyway, it's pretty easy, but here's the problem. A lot of people would take this first problem where it says find the next two terms of the geometric sequence 3, 5, 45, and they'd start saying, well, hey, 3 times 5 is 15, and then 15 times 3 is going to give me 45, and they'd start trying to guess, and that would be wrong. So that's why you have a common ratio. Okay, now this ratio means a number. And then this is a number divided by 1. 1 is just standard because your sequence, or the number to which you're going to subtract, is divided by something else. This is just a standard formula. What you all really want to do is use common sense and look at what is really going on. Common sense tells you that this 3 increased to 15 by some multiplicity of a number. And here it's done for you. So when you're doing your common ratios, if you look in your algebra book, it says the nth term, an, that's this number, of a geometric sequence with the first term, a1, and common ratio is given by a formula, and this is usually what's done. So, and this bar, of course, means to divide. So here you take your second term divided by the first, and you get 5. So guess what? That is your CR, or also better known as your common ratio. So this 5 you're going to use throughout trying to figure out what the problems are. And here's what you do. Okay, so now you take 45 and you multiply it by 5 and you get 225. Common ratio is used. So now you have 225 is what sequence? It's your fourth number. Yes? So then when you get ready to do it by your fourth number, you're going to take 225 and multiply that by 5, and that's going to give you your next sequence number. So there are your answers. Pretty straightforward. 225 is your fourth term, and 1125 is your fifth term. Now, if you were doing a problem and they were giving you some test writers were giving you this on a test, a lot of people would say, well, 15 times 3 is 45, 45 times 2, and they think they're going backwards. Well, 3 times 5 is 15, and 15 times 3. But guess what? If you were doing, you could say 45 times 2, and then 90 would be your next sequence. But then how do you get this 125? So it's not a part of the sequence. Okay. Your sequence is 45 times 3, and if you were to do your next sequence as 90, it'd be 90 times 1, which would be 90. How do you get this? This is the next number. Because then you'd have to go 90 times 1, and then you'd have to go into negative numbers, which would probably be like, then 90 times 0 is 0. That's not here. So 135 and 225, well, if 45 times 3 was 135 possibly, then how are you going to go 125? Is 125 times 2 any of your choices? 3 times 2 is 6. This is 7. It's 270. It's not. So, you know, this stuff here, if you're trying to guess through it, try to figure out what's going on. Okay, so you have 225 as your next sequence. These are your two choices. What's going on here? If you were to do 225, which we did on the other slide, and we got the answer, where do you get 675? Would you be taking 45 to get some number? So 45 times 3, is that going to give us, that gives us 135. Let's try 45 times 5 and see if that's going to give us some number. So that's 5 times 225. Yeah. See, we're not getting it. We're not getting anything that's 675. 45 times 7. It's 5. Carry my 3. 28, which is 31. That's 315. So we're still too low. So C is out. And process of elimination, this is our choice. 225, 1,125. So if you ever get caught and you think you're going to try to guess through, try to figure out how they're sequencing if you forget the formula. Okay, so next slide. What is the ninth term of a geometric sequence in which A3 equals 63 and R equals -3? So all of these are possibilities because our fourth term is 63 times negative is 189, -189. But guess what? Fifth term, negative 189 times -3 gives us a positive 567. 567 times 3 is negative 1,701. That's our sixth term. Okay, so seventh term, we get to by doing negative 1,701 times -3, which is 5,103. That's our seventh, and that's positive. And they're giving you a choice as negative. So that's out. Then we have positive 5,103 times -3, which is negative 15,309. Guess what? That's our eighth term. Did we want the eighth term? No, we want the ninth term. So that's out. So you're increasing, so you already know your answer is D, which is 45,927. But this 21 is a teaser to make you think that you're going backwards when you're not. So here's what you have to do. You have to know that this would be your division is what you're doing when you decide to go around and find out if you're going backwards. Okay, you're not going backwards, you're going forward. You're going from the third term to the ninth term, to the ninth term. And so you are now going to have to think in terms of progression, and progression, the numbers increase. Okay, when you're going backwards, usually they decrease. Now here's the thing, you have -3 into positive 63, which guess what, would give you a -21. So that's why that's a teaser, because there is a 21, but it's negative. If you have any questions, we're at jacobitslearning@gmail.com. Thank you for watching.